In this video, we're going to look at how we can determine whether two vectors are orthogonal or parallel, or of course possibly neither. And when we think of the word orthogonal, that really means perpendicular. So when we're talking about vectors, a lot of times instead of using the word perpendicular, they use the term orthogonal. And then of course that means that the two vectors are going to intersect at a right angle. And of course, if the vectors are parallel, that means that the two vectors will never cross each other. Okay, so we want to be able to look at two vectors and determine if they're going to be orthogonal or parallel or possibly neither. And the easy way to determine if two vectors are orthogonal is to simply take the dot product. If we have two vectors u and v, and if we take the dot product and the dot product is equal to 0, then vectors u and v are going to be parallel. I'm sorry, they're going to be orthogonal. So there how we determine orthogonal vectors. And if we want to look at whether the vectors are going to be parallel, then that means that the vector is going to be a scalar multiple of the other. So that means if we're able to take one vector and write it as a scalar multiple of the other vector, so here k is representing a scalar being multiplied by the vector. So once again here, k is just a scalar. So if you can write the other vector as a scalar multiple of the other vector, that means the two vectors are going to simply be parallel. So let's look at some examples. And then of course, if the dot product doesn't equal 0, and if it's not a scalar multiple, then that means the two vectors are neither orthogonal nor parallel. So the first example we have here, we have the two vectors 1, 2 and 2, 4. And let's first look at, and we'll call this, if this is u, and we'll call this one v. Since parallel is easy enough to detect, let's look at that. And the easy way to determine, and this one's obvious, I think, can we multiply either vector by a number and end up with the other vector? Well, to be able to look at that quickly, we can certainly just take the 2, if we take this 2 and divide it by the 1. So 2 divided by 1, what does that equal? Well, 2 over 1 is 2. And then if we were to take 4 divided by 2, 4 divided by 2 is equal to 2. Because these numbers are the same, that tells us that we could write this vector u, or I'm sorry, v, by multiplying 2 times u. So 2 times u, 2 times 1, 2. So 2 is our scalar. If we multiply this, we would end up with the other vector. So this tells us that the two vectors are going to be parallel. Okay, and it doesn't matter which way we divide. We took 2 divided by 1 and 4 divided by 2. If we went the other way and we took 1 divided by 2, we would get 1/2. And if we took 2 divided by 4, well, 2 divided by 4 is still 1/2. So again, we still get the same number, and that means we could take the second vector and multiply that by 1/2. And clearly, if we multiply 1/2 times 2, 4, we're going to end up with the other vector. So this is just a way to indicate that the two vectors would be parallel. So if you simply divide your x and your y coordinates and you get the same number, they will be parallel vectors. All right, the next example, we have one vector is 1/2, 2/3, and the other vector is 3/4, 1/4. And if we again want to look at this as far as being parallel, we could certainly take the 1/2 and 3/4, so that would be 1/2 divided by 3/4. And keep in mind that means we would take 1/2 and multiply by the reciprocal, which would be 4/3. And there we're going to end up with the 2 and a 4, so that would reduce to 2/3. And then if we take the 2/3 divided by 1/4, that means we would take 2/3 and multiply by the reciprocal 4/1, and here we end up with 8/3. And these two values are not the same, so that tells us that these two vectors are not going to be parallel. So they're not parallel. So then we could look at to determine are they going to be orthogonal? Well, if we want to test for them to be orthogonal, then we would actually have to take the dot product. So that means we would take here 1/2, 2/3, and multiply that by 3/4 and 1/4. So there we would have 1/2 times 3/4 plus 2/3 times 1/4. So that would give us 3/8 plus 2/12. So therefore we would have 3/8 plus 1/6. And really we don't have to go any further than this, because we know here this is not going to be equal to 0. So therefore they are not orthogonal. So that means here these two vectors are neither parallel nor orthogonal. Okay, so it's possible that they're going to be parallel, orthogonal, or neither. In this case, the answer would be neither. Okay, we'll try one more example, and this is one maybe you want to actually stop the video and see if you can figure this one out. If we have one vector to be 4, 2, and the second vector is equal to 1, -2, we can always test to see if they're going to be parallel. And I could take here 4 divided by 1, and then I could take 2 divided by -2. So we end up with 4 and -1. Again, these are not equal, so that means they are not going to be parallel. Oops. And again, they have to be the same number, because we have to be able to multiply one of the vectors by a scalar to get the other vector. So now, are they going to be orthogonal? Well, if we take the two vectors and we multiply them together, let's see, we get 4 times 1, which is 4, 2 times a -2 is a -4, and we get 4, -4 is 0, and because this turns out to be 0, the two vectors are going to be orthogonal, which really just means they're going to be perpendicular. And if we were to look at each vector, we have one that is 1, 2, 3, 4, so over 4 and up 2, and then our other vector is 1, -2, so we're going over 1 and down 2, and we can actually see just from kind of a rough sketch of the two vectors, it does indeed look like they would certainly be orthogonal. Now again, don't rely on looking at the graph, because this is not really that accurate, but it does verify that it does seem reasonable that they would be orthogonal. Okay, so once again, if we're looking for whether your vectors are going to be orthogonal, which means they're perpendicular, or parallel, orthogonal, we simply take the dot product. If the dot product is equal to 0, then the two vectors would be orthogonal. Or if you can take and multiply one of the vectors by a scalar and get the other vector, the two vectors will be parallel.